Good day everyone. So today we will discuss about the software development, chapter 7. What is software development? Software development involves creating, designing, programming, testing, and maintaining software applications or systems. It involves planning, coding, testing, deployment, and maintenance, and can be conducted by individuals, teams, or organizations using various methodologies. So, in software development, we follow a structured process. First, there's planning, where we brainstorm ideas about what our software or application will do and how it will function. Second, we move to designing, where we focus on creating the UI or UX, which stands for interface and user experience. This involves designing what the user will see and interact with. Next comes coding. Here we select a programming language that fits our software or application needs. We then write the front end or the client side and the back end server side. After coding, we move to testing. In this space, we thoroughly check the functionality of our software or application to ensure it works properly and is free of any issues. Once testing is complete, we proceed to deployment, which involves hosting the software on the internet and making it accessible to users. Finally, we have maintenance. This involves ensuring that our software or application continues to run smoothly, addressing any bugs that may arise and keeping it up to date with any necessary improvements or updates. And that's the basic overview of how software development works. Strategies for engineering quality resources. High quality software system. Software that works as expected and has fewer bugs. And software quality is a multidimensional concept that encompasses various aspects such as functionality, reliability, maintainability, usability, efficiency, portability, and security. Software defect. It is an error, flaw, failure, or fault in a computer program that causes it to produce an incorrect or unexpected result, or to behave in unintended ways. Software quality refers to characteristics like reliability, usability, performance, and security. From a process perspective, it refers to using disciplined methods and best practices that are likely to result in a higher quality product. Now, the importance of software quality. Business information system is a set of interrelated components, including hardware, software, networks, people, and procedures that collects and process data and disseminate outputs. Capture and record is a common type of business system. Another type of business information is decision support system or DSS. It's used to improve decision making in a variety of industries. Software product liability. Software liability is the legal responsibility of software manufacturing companies on any issues related to the software they develop. And that's why it's so interesting to your leadership. There are many scenarios where software manufacturing companies can be held liable for damages caused by software. For example, bugs in the code, security issues, intellectual property violations. The importance of software liability to operate efficiently and accurately today. Businesses depend on various software systems. A failure or glitch in any software they use can cause major incidents like service outage and data losses. causing severe financial and reputational damage to the business.
Software liability is a developer or company's legal responsibility for problems caused by their software. This may include things like bugs. If a flaw in the code causes the software to malfunction, resulting in financial loss or other damages, the developer may be held liable. Next is security flaws. If hackers exploit weaknesses in a software to steal data or cause harm, the developer may be held liable. Essentially, it is about accepting responsibility for any issues with the software that cause harm to users. Software liabilities are important because they protect users and ensure that software developers are held responsible for any damage caused by bugs or security vulnerabilities. It also promotes better software and encourages companies to create safer and more secure products. Furthermore, it reduces damages and can help cover expenses if software issues result in financial losses or data breaches. We have the software development life cycle. It is a process for creating software that meets users' needs and runs smoothly. We have six major stages. First is planning. Planning involves defining the software's purpose, features, and target audience, considering it like brainstorming and outlining a blueprint.
Software development life cycle. Analyze. Once you've come up with some ideas, it's time to organize them into cohesive plan and design. This requires a lot of research and planning to ensure that your final product meets your expectation. The big step is creating a detailed project plan, document and work breakdown structure that outlines the requirements. Next, design. Once you've got your design plans in front of you, it's time for wireframing and mock-ups. This step builds upon the planning stage, building out the tasks you need to do in the work breakdown schedule. There are plenty of tools available, such as Adobe or InVision, that make this process much as easier than before. Next, implementation. Once you've completed all the testing phases, it's time to deploy your new application for customers to use. After deployment, the launch may involve a marketing to your new product or service so people know about its existence. If the software is in-house, it may mean implementing the change management process to ensure user training and acceptance. Next, testing and integration. Before releasing the mock-ups into final production, you need to test it to ensure it is free of bugs and errors. Any issues need to be fixed before moving forward with deployment. You also need to manage how the system will integrate into existing systems, software, and process.
Number 6, maintenance. The final stage of the software development life cycle is maintenance and operations. This is one of the most critical stages because it's when your hard work gets put to the test. Maintenance involves updating an existing software product to fix bugs and ensure reliability. It can also include adding new features or functionality to a current product. Operations refer to the day-to-day running of software product or service, such as performing backups and other administrative tasks.
Hi, I'm Antoinette Ramos and I am explaining the development of safety critical system. A safety critical or a safety system is one which is responsible for carrying out safety action in the event of any postulated failure that can lead an accident causing loss a human life of property and or severe damage to the environment. So I cannot read this all kasi mahaba. So I can explain na lang what is development of safety critical system. So safety critical system are those that have a big responsibility preventing accident that could harm people, a property or the environment. to make sure that they work properly, or they can use safety tactics, or we can use the safety tactics. So, which are like strategies of staying safe, but sometimes it's hard to use these tactics kasi hindi naman maiiwasan yung mga bagay-bagay. So we are trying, or they are trying to improve the combining safety. And next. And the last slide is quality management standards. So what is quality management standards? This is the details of requirements, specification, guidelines, and characteristic that products, services, and processes should consistently meet in the order to ensure. So number 1 is their quality matches to the expectation. Number 2 is they are fit for purpose. Number 3, they meet the needs of their users. And the last one is standards are essential element of quality. And that's all. Thank you.